Action.
Another shot. Individuals, the objects described by a set of data.
Any characteristic of an individual. A variable can take different values from different individuals. A variable for Brayden is, Brayden wears glasses.
Categorical variable places an individual into one of several groups, such as glasses versus non-glasses.
Quantitative variables take numerical values which make sense to find an average. Like Riley and Zach here, who are 3 feet tall, and Nick and Jason, who are 6 feet tall. Bar graphs represents each category as a bar. Bar heights show the categories count or percents. They're easier to read and easier to make. A histogram is a diagram consisting of rectangles whose area is proportional to the frequency of a variable and whose width is equal to the class interval. To make a histogram, you divide the range of data into classes of equal width, find the count or frequency or percent, or the relative frequency of individuals in each class, and label and scale your axes and draw the histogram. The height of the bar equals its frequency. Adjacent bars should touch unless a class contains no individuals. A pie chart represents each category as a slice of pie. It must include all categories that make up the whole, and use a pie chart only when you want to emphasize each category's relation to the whole. I messed up that last part.
Draw a horizontal axis.
It's not
Label
fucking
a
focused.
variable name.
Okay.
Scale the axis from the minimum to the maximum value. Mark a dot above the location on the horizontal axis corresponding to each data value. In this specific situation, there's each number of goals per scored game by 2004 U.S. women's soccer team is being measured.
Our next graph is a stem plot, where we take a table of data and transfer it into a stem plot. To create a stem plot, we separate each observation into a stem, all but the final digit, and a leaf, the final digit. Write all possible stems from the smallest to the largest in a vertical column and draw a vertical line to the right of the column to separate the columns. Write each leaf in the row to the right of its stem. Arrange the leaves in increasing order out from the stem. Then, provide a key that explains in context what the stems and leaves represent. In this case, 4, the divider, and 9 represents a female student who has 49 pairs of shoes. A back-to-back stem plot is similar to a stem plot, but differs just slightly. A back-to-back stem and leaf plot is used to compare two sets of data. The leaves for one set of data are on one side of the stem, and the leaves for the other set of data are on the other side. They're constructed very similarly. You separate each observation into a stem, and then leaves on either side for both columns. Write the leaves for one set of data on the left side, and the leaves for the other set of data on the right. Then, afterwards, provide a key that explains in context what the stems and leaves represent, such as 4 pairs of shoes for a male student for the first key, and then 13 pairs of shoes for a female student for the second key. Examining the distribution of a quantitative variable. The purpose of a graph is to help us understand the data. After you make a graph, always ask, what do I see? To describe what you see, you look at the pattern of the distribution by its shape, center, and spread. To help you remember, we're going to CUS and BS. CUS stands for center, unusual features, shape, and spread. BS stands for be specific. This all equates to ways we can look at a graph and describe it based on its features and what we see the spread and makeup of it. Describing shape. When you describe a distribution shape, concentrate on the main features. Look for rough symmetry or clear skewness. A distribution is roughly symmetric if the right and left side of the graph are approximately mirror images of each other. A distribution is skewed to the right if the right side of the graph containing the half of the observations with larger values, is much longer than the left side. It is skewed to the left if the left side of the graph is much longer than the right side.
An important kind of deviation is an outlier. Outliers are observations that lie outside the overall pattern of a distribution. Always look for outliers and try to explain them. Like this jolly group of friends here that are best friends and have no loneliness, completely happy, and then we have this sad guy named Braden Shaw that's all alone with no friends that cries in the corner. Look at him. Sad guy. Oh, look at these guys over here. They're having a great time. And this guy's still crying. What is he doing?
Oh my god. The most common measure of center is the ordinary arithmetic average, or mean. To find the mean, or x bar, of a set of observations, add their values and divide by the number of observations. Here, we added all of these values together and divided by the number of values in the set, which was 8, to get the mean. Another common measure of center is the median. The median describes the midpoint of a distribution. The median, m, is the midpoint of a distribution, the number such that half of the observations are smaller and the other half are larger. To find the median of a distribution, arrange all observations from smallest to largest. If the number of observations n is odd, the median m is the center observation in the ordered list. Or, if the number of observations is even, the median m is the average of the two center observations in the order list. Comparing the mean and the median. The mean and the median are the same, only if the distribution is symmetrical. The median is a measure of center that is resistant to skew and outliers. The mean is not. When skewed left, the mean is more affected than the median and leans more towards the left. When skewed right, the mean is more towards the right and once again affected more than the median. The interquartile range, or IQR. A measure of center alone can be misleading. A useful numerical description of a distribution requires both a measure of center and a measure of spread. How to calculate the quartiles in the interquartile range. To calculate the quartiles, first, arrange the observations in increasing order and locate the median. The first quartile, or Q1, is the median of the observations located to the left of the median of all the data. The third quartile, or Q3, is the median of the observations located to the right of the median. To find the actual IQR in this set of data, we would take the third quartile, 42.5, and the first quartile, 15, and subtract. 42.5 minus 15 equaling 27.5, which would be the interquartile range, or the IQR.
Now the IQR is used to determine what is an outlier, whether positive or negative.
Take four. Take four.
Lights, take 4.
Camera,
It's take 4. Yo, it's your boy Bellus here. I'm gonna teach you how to find an outlier with the IQR rule. I'm ready, you ready? We're all ready. Alright, let's get a move on here. Alright, so you take the IQR here, which is 27.5. Alright, you multiply that by 1.5 times, and you add the third quartile here, 42.5. Anything above this number here, which is 83.75, is considered an outlier. Now to find anything below the first quartile for an outlier, alright, you take the first quartile, you subtract it by 1.5 times the IQR, and that gives you anything below this number is an outlier. But anything below 0 with this data here, alright, not possible. So anything below the first quartile is not an outlier, alright? Makes things easy, keep that in mind, alright? That's how you find outliers with the IQR rule.
So, we're going to be looking at the 5-number summary, which is quite basic, it's quite simple. We're just stating the minimum, the first quartile, the median, the third quartile, and the maximum. So, for this 5-number summary, our data showing these numbers here, we have 1, 3, 4, 7, 8, 9, 10, and 10. We can see that our minimum is 1. Our maximum is 10. Our median is, well, if we cross, we can get 8 there. Then our first quartile range, we can find a median between here and here, which is 4.
It's not the quartile range, it's just the first.
Oh, sorry, first quartile, that's what I meant. My British is kind of bad.
You're
Our
amateur.
third quartile would be, the final median between these would be 9. So, there are our values, minimum of 1, first quartile of 4, median of 8, the quartile of 9, and maximum of 10. It's a 5-number summary for this amount of data we have.
Alright, that was a great explanation, Jason. Thank you very much. Thank you. It's your boy Bellus here. That was a great explanation. Thank you.
One way to represent this 5-number summary is a box and whisker plot. The 5-number summary divides the distribution roughly into quarters, and this leads to a new way to display the quantitative data in the box plot. To make a box plot, first draw and label a number line that includes the range of the distribution. Draw a central box from quartile 1 to quartile 3. Note the median M inside that box. Extend lines, or whiskers, from the box out to the minimum and maximum values that are not outliers. On the left, we see a box and whisker plot and shows how what labels go with each part of the plot. And on the right, we have the plot labeled in context of the graph.
So, our maximum would be 17, our third quartile would be 14, our median would be 12, our first quartile would be S, and our minimum would be 1. Yes.
Yo, it's your boy Bellus here. That was great explanations from Jason and Braden. Alright, thank you. Go John, boss for your both. Fantastic. We're gonna take another 6
Ready?
months on the
A
film.
1, a 2, a skidly do.
It's your boy Bellus here, and I'm gonna teach you how to find standard deviation. It's the best golden stat you've ever seen, alright? I'm gonna teach you a lot how to find it. You know what standard deviation is? Well, I do. I'm gonna teach you a lot about it. Alright, basically, standard deviation is the average distance of all the values from the mean. It tells you a lot. It tells you how grouped together all the data is. It tells you how accurate it is, all that good stuff. Alright, so let's get into the details, the meat and bones, and how to find the standard deviation. Alright, so you find the mean here, okay? Which is 5. It's 5. And then you subtract that from all the points. Alright, for example, 1 minus 5, you get negative 4. Now what you do with that value, you do that for all of them. Alright, then you square that, you add them all together, you get this. Get this number, which is 52, alright? That's all these square numbers put together, alright? And then you take all the values, subtract by 1, and then you divide 52 by that, alright? And that gets you the variance. Now the variance, you square root the variance, and that gets you standard deviation. This is the meat, this is the beef stew you want, this is the good stuff, alright? That's the average distance from the mean, with all the values, alright? Good stuff, good stuff.
Thanks, Oh my
Well, thank you, Brandon. Thank you, Riley. And good job to you, Nick. You're the real hero behind the scenes. And
Is this like
that one guy filming.
Is this the ending?
Who's filming right now?